This video is about the latest and most dominant software architecture known as the cloud native architecture. We will go through about what is cloud native architecture and what are the properties of cloud native applications should have. Early days we had software running on a single computer that can be called as a single T architecture. With the advance of networking, we could able to distribute computing power from the local computer into a remote hosted place. The person who provides this cloud computer resources known as the cloud provider. In simply, cloud is offloading your computing and storage requirement to a remote hosted computer. So this make you having ultimate processing power, but you don't need to keep a large computer on your desk. You can get huge storage without adding hard disk into your computer. So this make revolutionize how mobile computing that we have today. So based on the accessibility of remote instance, we can divide the cloud deployment into three different categories: private cloud, public cloud, and hybrid cloud. Private cloud, also known as internal cloud and corporate cloud. Private cloud is hosting your program on your own remote infrastructure. This type of cloud restrict accessing the cloud services from the outside users. This allow access only for selected set of users to access the private cloud. So you have full flexibility of what you have. You can customize your infrastructure and software as you want. Good security as it is not shared with anyone else. The data you have managed by yourself. No third party can access your cloud. There are some downside of private cloud as well. Private cloud is much more costly due to its maintenance and setup cost. You need to have a set of people who have skill to manage the cloud, and that costs money. In private cloud, you need to grow your system, then you need to buy more CPUs and memories, so which also take monies and expertise. We can think of more cost effective solutions. Instead of keeping data on your own private cloud, you can host it in a shared place. Now, not only you, others who need to host their services can also host in this shared cloud. So, this is what we call as the public cloud. Public clouds are much more cheaper than private clouds. So you don't need maintainer to maintain your cloud, and simply you can deploy it. The rest of things, the cloud provider do it for you. Another advantage is that you can start with a smaller capacity first and then scale on demand. You can scale nearly unlimited until you meet your business requirement. So there are few concern on public cloud as well. Since this is in a shared place, other organization also has access into the cloud provider. So security is a concern that you need to think about when you're having public cloud. On the other hand, once you move into the public cloud, you need to think about the cost when your system getting more and more users. So make sure you haven't vendor locking in and do a proper cost management. The hybrid cloud is the best of both worlds. Here you can use both private cloud and public cloud working together in your system. You can deploy your system component on both type of cloud in hybrid manner. Hybrid cloud is much cheaper than private cloud, flexible and more scalable than public cloud, and secure than public cloud. But due to the hybrid nature, it also becoming complex to implement and maintain. Cloud providers provide different types of services to their clients. Here are some of these services. Software as a service or SaaS, platform as a service or PaaS, infrastructure as a services or IaaS. You might use SaaS application in your everyday life. If you have used Google Drive, Dropbox, or Salesforce, then you have already experienced what is SaaS is. SaaS is providing software as a solution to their end users. That might be storage, email, or any type of business management solution. On the other hand, PaaS is a platform as a service, is to provide a platform for you to develop your applications. So if you need to develop some business application and host it on the cloud, then you can use PaaS services such as Hello Google Apps Engine, and OpenShift. If you need to develop application and go much deeper into an infrastructure level, then you can use IaaS or infrastructure as services. This will provide infrastructure level abstraction where you can select what CPU, hard disk, and operating system you want to build, and build on these in these services. So popular IaaS include AWS, Google Cloud, and Microsoft Azure. In business owner perspective, you can start your business with SaaS services which are already available. It is simple and cost effective. If you need more customization, then you can create your own SaaS app by running by using a pass. If you need a further customization and avoid vendor locking, then you can think of moving into the IaaS solution. We have discussed about what is cloud, but what is cloud native? Cloud native is a term typically used when referring to architectural style, practices, and tools that are needed for applications deployed in a cloud computing environment. So this architecture is agile because it takes the advantage of cloud ability to respond quicker in based on the user demand. The primary goal of this architecture is availability and resiliency by ensuring the developer actions are automated. So there are a list of properties that you need to consider when you're building a cloud native applications. Statelessness, modular design, isolation, automated delivery. So these are the important characteristics of microservices architecture. This is where microservices are coming into the cloud native architecture. Cloud native services are not supposed to store status by its own. Rather, it should only process data and store information on a database. But why? Statelessness nature is really important when you are building applications that can scale up. You can easily scale up the system by adding more CPUs and storage. This is known as the vertical scaling. We can also duplicate the services into different computers. Then we can also distribute the workload among them. So this is known as the horizontal scalability. Bob is a user and he need to place an order. Think a request comes into the first service and keeps some information related to the Bob's order. We cannot guarantee that the next request from the Bob's goes to the same service. What if the request goes to the second service? Definitely it will get failed. What if we use a central database instead of keeping status in each of these services? Now, Bob's order status can be kept on a central database. He can access order service by calling any order service. As you can see, statelessness nature of these services make horizontal scalability is possible. Cloud native application should not be big single machine that does everything like order management, customer management, handling payments. Each service solves a particular business domain. For example, order service is to adding, deleting, validating, and updating orders. Customer service onboarding new customers and manage them. Payment service managing financial transaction. So if one service need data from another service, then they can just simply communicate with each others. Common problem in software development is that application working in locally, but when you're deploying it to production, it get fail. Here, the problem is the difference between the development environment and the production environment. So, how you can make them similar as possible? Most of these differences are due to the execution environment changes such as operating system, dependencies, configurations, and so on. Isolating services is important as it can be run on many different environments. You can simply include all of your dependencies, including your application artifacts, operating system, dependencies, and configurations into single image and send it to the deployment. This makes your application work independently from your host computer. So one of the best and simplest way of keeping this component is by using a virtual machine or by using a container. But containers dominate the microservices as it is lightweight than virtual machines. Services in microservices architecture are supposed to be smaller, but this would be also lead to another problem. When system getting bigger and bigger, and if you have many deployable services in your system, then managing them manually becoming a nightmare. At this point, you need to think about how you can automate your deployment process. So we can do this with three steps. Build pipeline to generate artifact from the source code. Check the validity of changes with the test automation. Deploy the artifact on the deployment. First, the developer generate required code changes and push it to the source code repository. Build pipeline generating artifacts that require deployed in the deployment. Jenkins, GitHub Actions, Travis CI, and many other delivery pipeline tools can be used to implement this. These tools can read your source code and generate deployable artifacts such as Docker images, executable files, dependency modules, and so on. So once those artifacts are generated, you can keep it for the deployment requirements. While and after this artifact generation, you can set up a testing framework to run tests. These tests are important in validating these artifacts and that the developer has generated. So finally, you can deploy your artifact on your deployment. So this deployment can be a Docker container, a Kubernetes cluster, a virtual machine, or just a bare metal server. Why you should select cloud native architecture? Cloud native is becoming more and more prominent on building cloud applications. Cloud native applications are much scalable and make cloud operators to easily scale up or scale down based on the system requirements. Since the cloud applications avoid single point of failures by replicating services, it is more reliable than monolithic applications. With the use of automated delivery pipelines, we can easily roll up updated with newer versions. And there are many tools available in the internet to manage cloud native application deployments. Having deployment in cloud is cost effective because you can simply deploy your services in a shared cloud. You can select pricing schemes such as pay as you go model. It makes your cloud based developers to kickstart their innovation with low cost. On the other hand, there are no limitation of selecting programming languages or dependent libraries to build your services. You can simply select whatever programming language that best fit your requirement and implement it. With a container or virtual machines, you can simply deploy it. With the deployment pipeline, you can make development more agile. There are challenges associated with the cloud native architecture. Security become a huge concern as there are many moving parts in the deployment. You need to make sure that all the communication links secured properly and take proper security precautions while building your cloud native applications. Due to the distributed nature of this cloud native application, the complexity become the integral part of the system. You can follow standard best practices and design patterns to simplify these complexities. We will discuss about those practices in upcoming videos. Cloud locking is not specific to the cloud native. So when you are selecting vendors and technologies for your application, always keep on mind to minimize the locking in specific technology or any other service providers. Try to avoid vendor locking and try to use open source project as much as possible. As a context, cloud native is a game changer. It changed the typical way of building software application. In upcoming videos, we will learn how to build cloud native applications and what are the things you need to consider when you are building a cloud applications. That's it for now and see you in next video.